speed, velocity, and acceleration. I can differentiate between speed, velocity, and acceleration. Your starter. An archer shot a .06 kilogram arrow at a target. The arrow accelerated at 5,000 meters per second squared to reach a speed of 50 meters per second as it left the bow. During this acceleration, what was the net force on the arrow to the nearest Newton? So you would go to your star reference guide and you would find your formula for net force. Net force equals mass times acceleration. So we're going to use this formula for net force and substitute our numbers. Our formula, net force equals mass times acceleration. So the net force equals, we're going to put the mass of the arrow, which is .06 kilograms, and multiply it by the acceleration of the arrow, which is 5,000 meters per second squared. When you multiply those two numbers, mass and acceleration, your net force equals 300 newtons. A mother and daughter press their hands together and then push apart while ice skating. Immediately after they push away from each other, how does the motion of the mother and daughter change? So first you want to look, the mother has 100 kilogram mass and the daughter has 50 kilogram mass. So the person with the lighter mass is going to have a greater acceleration if your forces are held constant. So look, the mother is pushing with 15 newtons of force, and so is the daughter. So the forces are constant, but the object with the smaller mass will always have the greater acceleration. So we can say both mother and daughter are going to move backwards, and the daughter is going to move with a greater acceleration. The same amount of force is used to push the carts. Which cart would have the greatest change in acceleration? So very similar to our last problem, what you want to understand is the forces or are the forces held constant? And in this situation, yes, they are, because we're using the same amount of force to push the cart. So the cart with the less mass is going to have the greatest change in acceleration. So here you have to be very careful about your numbers because they're trying to trick you with what they have in the cart. But the amount or what the object doesn't matter in this scenario. You just have to look at which cart has the smallest mass. And if we look here, cart A has a 10 kilogram mass. Cart B has a 15 kilogram mass, cart D 25 kilogram, and cart C 20. So the cart with the smallest mass is going to be the one with the 12 rackets. So if forces are held constant and you push on these carts with the same amount of force, the cart that has 10 kilograms is going to have the greatest change in acceleration because in theory it's the lightest. And objects that have the lightest mass are going to have the greatest change in acceleration. So we can have the greatest change in increasing or decreasing speed or even changing direction in this scenario. So for your practice activity and connection today, we're going to complete the speed, velocity, and acceleration notes while watching my instructional video. So at the same time, you can pull up your assignment and pause my video as I read to you. Motion is a change in position relative to another object. How fast an object is moving is called speed. Speed is how far something travels, distance in a given amount of time. The formula for finding speed is speed equals distance divided by time. The unit for speed is meters or kilometers, that's your distance, and seconds or hours for your time. It looks like this: meters per second or kilometers per hour. Sometimes it is important to know speed and direction an object is traveling. Velocity is the term when referring to speed and a vector of direction. So you might say the car is traveling at 50 meters per second north. Vectors can be used to show the direction of an object's motion. Which of these shows speed and which shows velocity? So remember, speed is simply how fast or slow an object's moving. Velocity is going to be speed with a direction. So here, this example, 25 meters per second, that's simply speed. Look at the units. It's distance and time. There's no indication of direction here. This example, 67 meters per second north, would be velocity because it's giving you speed, 67 meters per second, with a direction north. Down here, 90 meters per second, but they're giving you an arrow, a vector, which indicates direction. So this would be an example of velocity. 90 meters per second squared, we can say up, or we could say north. 13 kilometers per second, an example of speed. Acceleration.
Bulldozing to small and speedy, NFL running backs come in many shapes and sizes. But to succeed in football, all running backs must excel at kinematics, the branch of classical mechanics that defines how objects move.
Because kinematics describes motion, it describes everything an NFL running back does, basically, which is his motion up the field as he tries to score.
Kinematics uses three concepts to define motion: position, velocity, and acceleration. Position defines location within a space, such as the surface of a football field.
Position would be the running back's location on the field, and he can change that with his motion.
In this play, let's define the running back's position where he takes the handoff. After executing the play, however, his new position is his opponent's end zone.
The position relative to the goal line changes the set of options that the running back has in terms of the direction he chooses to run.
A second kinematic concept is velocity, which describes both the direction and speed of the running back. In the NFL, one-way speed is measured is a player's time in the 40-yard dash.
A long time ago, almost right at 10 years ago, my 40-yard dash was 4.26.
To help illustrate the concepts of kinematics, Deuce McAllister, all-time leading rusher for the New Orleans Saints, ran the 40-yard dash in front of a high-speed Phantom camera.
You want to stay low as possible while running the 40, particularly the first 10 yards. So it's literally like you're being shot out of a cannon.
Using McAllister's personal best in the 40, 4.26 seconds, it's easy to calculate his speed. Divide the distance by the time to get his average speed, 9.39 yards per second, or 28.17 feet per second. To define the velocity, simply add a direction, 28.17 feet per second north.
When we talk about speed, we're talking about the magnitude of velocity, and then its direction is dictated by where the running back goes.
On the field, great speed is used to elude tacklers.
When you have speed, and you have very good speed, that 5-yard play for most backs becomes a 50-yard play.
Also helpful is the ability to cut or suddenly change directions.
That helps you make moves against a defender. That helps you stay free from getting tackled.
Beyond position and velocity, the third kinematic concept is acceleration, which describes how fast speed is changing.
You never know when you may need to hit that button, per se, to accelerate at maximum speed.
To understand acceleration, consider again McAllister's 40-yard dash. While his average speed is 28.17 feet per second, his instantaneous speed varies. He starts with 0 speed and then increases his speed or accelerates until he reaches a top speed, let's say hypothetically 31.5 feet per second. If we know how long it takes McAllister to hit his top speed, let's assume 1.2 seconds, then it's possible to calculate his acceleration as the change in speed divided by the time.
Acceleration is the change in velocity per unit time, which if we compare it to velocity was the change in distance per unit time.
In this case, 31.5 feet per second divided by 1.2 seconds means that McAllister's acceleration was 26.25 feet per second squared.
We want to reach our top velocity as quickly as possible. Someone with very low acceleration might take 5 yards to reach top velocity, while someone with great acceleration might be able to reach top velocity in half that distance.
On the playing field, acceleration, or the ability to reach top speed quickly, may be a running back's most potent weapon.
If you can accelerate, you're going to get to top speed. Even if your top speed isn't as fast as the guy that's faster than you, you're going to beat him to his top speed. Therefore, you're going to be more successful than he is.
Without kinematics and its concepts of position, velocity, and acceleration, NFL running backs would be easy prey, and football itself wouldn't be nearly as fun to watch.
When force is applied to a moving object, the object can speed up, slow down, or come to a stop or change direction. When a force changes the speed, direction, or both of an object, it's changing the velocity of the object. Velocity is distance divided by time with direction. A change in velocity is called acceleration. This is the change in velocity over a given period of time. The formula for acceleration is measured in meters per second squared or meters per second squared. Acceleration equals velocity divided by time. An object falling to Earth is subject to a change in acceleration of 9.8 meters per second squared due to gravity. Examples of acceleration are stepping on the brakes or slowing down, pedaling your bicycle faster or speeding up, or change in direction.